So, hey guys, hope you're doing well. So, today we're going to see one of the most important concepts of networking, which is going to be DNS. You might have heard of DNS. You might have heard of Google DNS, which is 8.8.8.8, or you might have heard of multiple other DNS servers. So, let's get straight into what a DNS server is and how it works. So, let's say a client wants to actually communicate with the server. So, the client let's say I want to visit www.cisroute.com, right? Let's say we type this into our browser. Now, what's going to happen? Is the server automatically going to know that what is cisroute.com? Actually, no. Because whenever we type a domain name, the domain name is especially readable for us and it's not readable for the server. So there has to be a middleman who going to help us to translate these words, which is this is route.com, into an IP address. And that's exactly why we need a DNS. We need a middleman who can translate it. So now let's see what DNS is going to let us do. Now let's say again the client wants to communicate with the server and we are typing www.cisroute.com. Now DNS is going to be a middleman and he's going to translate this www.cisroute.com into an IP address, which is let's say 10.10.0.0.1. And now the server would be able to understand, okay, you are reaching out to me. So the client is going to be now requesting from 10.0.0.1, which is the IP address of the server, and now the server is going to be like, okay, 10.0.0.1, I got you. And now it's going to respond with the 200, which is connection established. And this is exactly why we need a DNS server. We need a DNS server because we want to translate any DNS query that we do in our browsers to a IP address. And this is exactly why DNS is very important, because whenever we do not have a DNS server, we cannot reach the IP address which is assigned to the server. And we won't even be able to see that website. Let's say we are typing google.com. We can't even see google.com because the DNS has to work properly for mapping google.com domain name to a specific IP address so that we can exactly reach out to that server. Now, let's see the process of DNS lookup, right? So, there are multiple steps that are involved in terms of DNS, in terms of the working of the DNS. Now, let's say our client has to do a lookup of www.cisroute.com, right? Now, what is the client going to do? First, the client is going to check its own cache, right? Its cache memory. So first, it's going to check its browser cache. And in the browser cache, if you have already typed cisroute.com, it's actually going to appear already. And if the browser cache does not have it, it checks its local cache, right? The machine has its own, let's say you have a PC and the PC has its own local RAM. And then it checks its local RAM and then says, okay, I do not have it, let's say. Let's say you are visiting this website for the first time. So the client would be like, I do not have this. So now what happens is there has to be a DNS request that has to be made to the DNS resolver. Now, DNS resolver is actually configured in two ways, right? One is it might be manually configured, which in where you just go to that specific your network settings, and then you say, okay, use this DNS server 8.8.8.8. That is one way of configuring it. And the other way of configuring it is automatically by using DHCP. So DHCP stands for Dynamic Host Configuration Protocol, which basically lets the client automatically assign the IP addresses to itself, right? So whenever there is a DNS lookup, either DHCP server assigns a DNS IP address to the client, or the client already has a manually configured IP address, right? So let's say we are using a manually configured IP address. Let's say we already manually configured in the client that please use 8.8.8.8 as the IP address. And now what is going to happen? The client is going to send a UDP request, right? To what port? To port number 53. So 53 is the port that is used for DNS resolution, right? How does the DNS resolver identify that it's a request for a DNS, right? So it sees the port which it's going to go to. And the port here is 53, which is assigned specifically for DNS servers. And the destination IP address from the client is going to be 8.8.8.8 since we have configured the DNS to be 8.8.8.8. Now is where DNS resolver comes into play. So DNS resolver is going to make various lookups, like it's going to make three lookups. But since it's making three lookups at the same time, that's why it's called a recursive DNS query, right? Now let's see how this recursive DNS query works. So the DNS resolver first checks its own cache and sees, no, I do not have the IP address, which is sysroute. So let me first request the root DNS server. So the first request goes to the root DNS server, and the root DNS server actually sees which top level domain has the IP address. What do you mean by top level domain? So top level domain is the last few digits or last few letters of your request. So let's say sysroute.com, the last few is actually .com. So root DNS server, it would give us the top level domain server for .com. So root DNS server would say, okay, you're searching for .com. I have to give you the top level domain server who has access to the .com domain. Now let's say if it's .in or .in, right? Let's say google.in. So in terms of .in, again, there would be a different top level domain server, which is actually pointing towards that IP address. Now root DNS server would now, in this terms where we are searching for google.in, it would give the top level domain server of the .in domains, right? So here it's going to give us .com domain, and that is the TLD server's IP address, which has the .com domain. Now DNS resolver gets this IP address and again makes a request number 2. This time it is going to request the top level domain server. Okay, top level domain server, which is the .com domain, please help me to identify the IP address. Now top level IP address, top level domain server is not going to have the IP address as well. So the top level domain server is going to send the next DNS server's IP address, which is going to be the authoritative DNS server's IP address. So the top level domain server is going to think, okay, which authoritative DNS server might have my IP address? And then the top level domain server again returns the authoritative DNS server's IP address. And this authoritative DNS server's IP address, again, there is a request which is going from the DNS resolver to the authoritative DNS server. And finally, the authoritative DNS server will have a mapping. So it will have a mapping stating that the sysroute.com's IP address is 10.0.0.1. So now let me give you this IP address back so that you can actually, send it to the client so that the client can finally reach me, right? Now the response goes back that 10.0.0.1 is sysroute.com, and finally the DNS resolver would again give that same information to the client that you're searching for www.sysroute.com. So let me give you the IP address now. So now we have the IP address mapping, right? We have an IP address mapping stating that it's sysroute.com. Now the client can finally reach the sysroute's server by using the IP address in port 80, let's say. And finally, the sysroute server would be able to give you a response, which is the HTTP OK. So all of these steps has to happen in sync in order for the DNS lookup to happen. And it all happens in a fraction of a second, and that's the power of the internet, right? So now let's see what is a DNS record. So a DNS record is basically like in authoritative DNS server, there has to be a logical segmentation between small records. Records means, let's say we want to search for an IPv4 address. So in that term, we have an A record. let's say we want to search for an IPv6 address. In that terms, we have quad A records, which is AAA records, right? And let's say uh, there is an there is a subdomain. Let's say google.com has a subdomain which is called g.google.com, or let's say labs.google.com, or let's say gemini.google.com, right? So these are called CNAME records. So whenever the main domain, which is google.com, is assigned to some small subdomain like CNAME, like g.com, something like that, that's when we have a CNAME record. Next, we have MX record, which means, let's say I'm searching for www.google.com and I want to speak to a Google employee. So in that terms, his mail address would probably be hari@google.com, right? So that is a mail address. And that mail address is holded by MX records. So all of these four records are stored in the authoritative DNS server, and the authoritative DNS server will respond with either one of these records depending upon the request. So those are DNS records. Finally, we are concluding. So DNS translates domain names to IP addresses. So next thing is, it can be manually configured or automatically configured by DHCP. If we are manually configuring, we have to go to the IP settings of our specific client and say that client, please use this IP address, which is maybe 8.8.8.8, which is the Google's DNS IP address. Or we can have Cloudflare's IP address, which is 1.1.1.1, or any other DNS server's IP address. If it's automatically configured, it's automatically going to use the ISP's IP address, DNS. Now, again, next thing is we have a hierarchical name system, which is, first, the client has to use the resolver, and the resolver will do a recursive DNS query, first to the root DNS server, second to the top level domain server, and third to the authoritative DNS server. And usually all of these people, they use caching to reduce latency and traffic. And mainly DNS operates in UDP, which is port number 53. And in terms of TCP, the TCP handshake will only happen, UDP will transfer into TCP only when the records are more than 512 bytes, right? So let's say we are getting a response from the DNS server stating that all the records are present, right? Let's say we are searching for an A record. All the records are present in that specific DNS query. But now, if the bytes are more than 512, right? In terms of this, then TCP has to take place, because TCP is the only one that can make sure that the packets are coming in ordered fashion, right? If it's more than 512, I cannot send it in an ordered way. I'll send it as a UDP. But if it has to go more than 512, the truncate bit in the DNS query will be set to 1, right? When truncate is set to 1, the client has to make another request which states, please give me the record in terms of TCP. So there has to be a TCP handshake established between the resolver and the client. And then once the TCP handshake is established, again the DNS will communicate with the server, and finally we'll get the IP address after the TCP handshake has been done. Now, what happens if there is a failure in DNS, right? Let's say the DNS resolver is not working properly. So now what happens is, the website appears unreachable despite the server being up. So let's say I'm searching for google.com and I don't have the IP address of google.com, and the DNS resolver is not giving me the IP address. So then I can't even reach google.com at the first place. So these are the very, very important concepts of DNS servers, and I hope you enjoyed this video. There are more videos coming on DHCP and how domain lookup happens, etc. So I hope you stay tuned. I hope you enjoyed the video. Thank you.